As a scientist, I'm very interested in puzzles and how we can reduce complex systems to very simple questions that will then have profound impact on our understanding. But one interesting discovery then just sets up the next challenge, and so I've always felt like I'm chasing something. I think people are, they're always interested in the brain just because it's such a mysterious organ and, it's the essence of who we are. In the back of my head, I think I had an idea that it would be really interesting to work on problems related to the brain in a simple way, in a reductionist way. Recognize that I could start to think about certain brain problems as biochemical problems. There was an essential breakthrough that we had that came with a realization that this tau protein that underlies the dementia in Alzheimer's has this ability to sort of self-assemble, and it can form discrete structures. And what we figured out is that these structures, once they form in a cell, can move from one cell to another throughout the brain. But it got a little more interesting because we realized that this phenomenon of replicating one structure or another turns out to provide the key to understand why we can get a whole diversity of different neurodegenerative diseases that are linked to the tau protein. Alzheimer's disease is by far the most common disorder of the tau protein, but there's over 20 or 25 other neurodegenerative diseases that also are caused by accumulation of the tau protein. And it turns out that when we looked for distinct structures, we could see that different syndromes were associated with different constellations of structures. And this holds the key, we think, to essentially personalizing treatment for patients with neurodegenerative disease, figuring out which structures are involved in their particular syndrome and then figuring out therapies that would target these structures particularly well. We're just in that first step where we're hoping for that breakthrough that just changes the trajectory of the disease even a small amount. But I think that that's likely to come to pass in the next few years. If we can slow down these horrible diseases or preferably stop them, there's just a lot of human suffering that we could avoid.